Good morning, everybody, and welcome to the 5.9 lesson, which is going to be on arc length and sector area. So we will kind of keep going with our trend of doing some angle chases next week, but we need to introduce basically a new character, which is going to be the circle. And there's a bunch of angle relationships in there. Today and tomorrow's lessons might be kind of a bit of a sidestep towards getting towards that, but there are some important characteristics that we're going to need in regards to circles that are currently missing. So within this lesson, our goal is kind of twofold. One is going to be able to figure out basically if I have to travel a limited distance along a circle, how I would figure out that arc length, and that's going to come with some additional vocabulary. And we also have how do I figure out the area of a sector? And a sector of a circle is just basically a slice of that circle. So this is area. Okay, so this is a two-dimensional kind of space here that we're looking to find the area of. And then with arc length, it is the one-dimensional distance along that curve from C to D. So as we kind of talked, I said there was going to be some additional vocabulary. So what I want to introduce at this point is basically this angle that we have here is called a central angle. So that central angle is 62 degrees. And one thing that's kind of important about that is a central angle, like one way to measure this arc CD is to say that this is also 62 degrees. We can measure arcs in two different ways. One is basically in a distance measure, so the distance along the path from C to D, and then the other is in a degree measurement. So as a degree measurement, we could say that arc CD is 62 degrees as well. So the relationship between a central angle and the arc is actually 1-to-1. So if that central angle was 50 degrees, then we could say that that arc is 50 degrees as well. And that makes sense basically as I go all the way around the circle, I get 360, so on and so forth. And the way in which we would figure out basically just what that limited distance is, or the specific measurement from C to D here, is to figure out the entire distance around this circle and then just take the appropriate portion that we want. So the entire distance around that circle is going to be 2 pi r, right? It's going to be our circumference equation. So 2 pi r in this case is going to be 2 pi times 5. And that is the entire distance around that circle. But because I'm only talking about a portion of it, the way that I normally visualize this is I say, well, okay, what if I only went 1 degree around that circle? Okay, so if I only went 1 degree around that circle, well, then that would be 360ths of that entire path. Okay, and then obviously if I want to go 62 degrees of that, it's just going to be 62 of those little tiny fractions. So this should end up giving me my result. And if I plug this into my calculator, I'm just going to say 2 pi times 5 times 62 divided by 360. I end up with this 5.410, but I'm just going to leave it as is. And this is in one-dimensional space, so I would say centimeters. And if I compare that to my radius, that seems about right. Okay, so my radius was 5 centimeters. And if I tried to mold basically that radius around the outside of my circle, I could see, that's around where I was getting. So if I got something like 15 or something like 2, I would probably want to kind of double check my work on that. Otherwise, I can just leave it as is, which is fine. We can do this same thing if I have to do it in radians. Radians actually ends up being a little bit nicer in this particular case, and that is because, one interesting component that we talked about with radians is it's the number of times that that radius can get wrapped around my circle. So this is almost already set up to be used to figure out this distance right here. All I have to do in this case to figure out that arc length is to take my angle in radians and multiply it by 4.5. And that is going to end up giving me my answer. So if I plug that in, end up getting 5.6. Again, just kind of a visual inspection, appears to be about right for that rotation, kind of within the realm of reasonableness, so I'm good to move forward. So for arc length, the key I would say is to figure out proportionally, what ratio of the circle that we actually want, and then do the division, multiply by my radius, and I'm kind of all set at that point. Looking at sector area, this isn't going to be very different, except we're going to be taking the proportion of the area that we have here. So this is just going to be the entire area of the circle, and then multiplied by the proportion that I'm talking about. Here we can also see that they told us basically that arc measure is 25 degrees, and that's helpful because we know that our central angle is then 25 degrees as well. So the portion of the circle that I'm trying to figure out is this 25 over 360. And then the area of that circle is pi times my radius squared. So this should be my equation. I'm just going to kind of plug this in, figure out what I get. End up getting 5.45. Again, as soon as we start getting into area, it becomes a little bit harder to figure out the reasonableness of it. Probably a few different ways that you could visualize it if you wanted to. I'm just taking a look at this like, oh, okay, this whole square right here would be 25, because that would be my radius squared. And I'm looking at about a fourth or a fifth of that, so seems to make sense. So for generic equations, if I had to do this, I would normally say, oh, okay, my arc length is going to be 2 pi r, or my circumference, times theta over 360. Obviously, this is if we are in degrees. And then similar for my sector area is area of a circle times my angle divided by 360 degrees. For in radians, arc length is actually pretty nice. It's just radian times my angle. And then sector area in radians, I don't know that there's any great relationship between the two. So I actually might just recommend doing pi r squared times your radian measure over 2 pi. That ends up kind of giving us that same result, or that same proportion of the circle. There are about 12 problems in which are going to be figuring out arc length and sector area, going back and forth. And then there's also a challenge opportunity, which is optional. So feel free to also just take a look at that and kind of see what some of those tricky questions are like. And if you want to take a stab at them, you're welcome to. Thanks, everyone.